Hi everyone, my name is Julia.
I'm Tara.
I'm Malaysia, and for our project, we will be doing autoimmune hemolytic anemia. So, table of contents, we're gonna have a couple things happening. We're gonna first have a guest speaker, and then I'm going to go into what is autoimmune hemolytic anemia, such as descriptions and symptoms. And then we'll have statistics and overview of the innate and adaptive immunity with graphs included, and a section for questions and comments. First, we'll have our guest speaker who has graciously been able to answer a couple questions for us on the disease. So, autoimmune hemolytic anemia is a condition characterized by autoantibodies that react with self-red blood cells and cause them to be destroyed or lysed. Some symptoms of anemia are the paling of the skin, yellowing of the eyes, and shortness of breath in the respiratory because we know blood cells carry oxygen. In more severe cases of anemia, you'll have fainting, chest pain, and even heart attacks. So, types of hemolytic anemia, you have inherited and acquired. Some inherited are sickle cell anemia, pernicious anemia, and B12 deficiency anemia. For acquired, you have autoimmune hemolytic anemia, which is what we're focusing on with their two subunits. You also have a drug-induced hemolytic anemia as well.
So, in the innate immune system, macrophages aid in the removal of damaged cells through phagocytosis. For example, it is the red blood cells that are affected by hemolytic anemia that are getting removed by the macrophages. Macrophages mainly focus on cells that are marked by antibodies and attempt to avoid healthy cells. Autoantibodies, however, mistakenly tag a person's own tissue, in this case causing the macrophages to target the tagged red blood cells. There are certain types of Fc gamma receptors that can regulate phagocytosis, meaning it can kind of slow it down when it's bind to IgG. And therefore, since phagocytosis is regulated, then cell lysis is also regulated. IgG dimers increase binding affinity to these specific Fc gamma receptors because an IgG dimer is basically two IgGs put together, and this provides an inhibitory effect as shown. As you can see, the black bar is going to represent the control. So this is basically going to be representing the one IgG, while the white bar is going to be representing the IgG dimer, so basically the two IgGs put together that happen to have a higher binding affinity, which lowers the macrophages and the rate that those macrophages are going to be phagocytosing and causing cell lysis.
Okay, so now we're moving on to the adaptive immune system. So in the adaptive immune system, T regulatory cells are a vital component to the immune system because it helps to maintain a self-tolerance, which prevents the development of autoimmune diseases. If your T regulatory cells are not working, this can cause your cells to act inappropriately towards its own cells and inevitably cause diseases like this. So in this experiment, scientists took mice and they injected them with rat red blood cells. And this was to mimic the response of someone who has this disease. And they took those two mice and had the control group, which was just the rats that had the red blood cells alone. And then they injected another couple of mice with anti-CD25 antibodies. And this was basically to block or deplete CD25. And what they found out is that the rat red blood cells that had anti-CD25 had a greater response to this antibody. So they were basically worse off compared to the mice that just had the rat red blood cells alone.
So for a summary of the innate graft, we have to remember that autoantibodies inaccurately tag red blood cells causing immune or autoimmune hemolytic anemia. Innate immunity involves macrophages that phagocytose the erythrocytes tagged with the antibodies. Specific Fc gamma receptors bind to IgG, which regulates phagocytosis. As shown in the graph, IgG dimers have a higher binding affinity to Fc gamma receptors, which better regulates phagocytosis.
So T regulatory cells like CD4 and CD25 are vital in recognizing antigens, and as shown in the graph, a depletion or blocking of T regulatory cells increase the likelihood of the progression or development of autoimmune hemolytic anemia.
And here we just have some of our citations. And now we have any questions or comments that might come for when we do present.